So we are dealing with another frame. We have been dealing with knee frames, knee frames. This is a complete frame this time. We want to deal with those knee frames has only one support. That's support A. So we don't need to start calculating reactions. But here there are two supports at A and B. This is not a knee frame. So here, for us to deal with this, we have to get what exactly are the values of the reactions at A and B, because we don't know. But in the other one, we know that there is only one support. This one, there are two supports. So we now, to calculate the reactions, we have, I want to calculate reaction B, reaction A, MB, all moment about B is equal to 0. Because the support at B does not sustain bending moment. So I have 8 times reaction A. To make reaction A moment, I say it's positive. I decide that it's positive. Then the 6 is at a distance of 4 meters. That's at the middle. So reaction A is going this way, which is positive. Then 6 is against it, minus 6 times 4. About reaction A, perpendicular distance, perpendicular. 6 is perpendicular to distance. If the point of 6 is E, is the 6 kilonewton force is perpendicular to the distance ED. Distance ED. So that is the one that it is, but ED is not perpendicular to DB, it's not. So it's based on ED, so that's why it was used to multiply, even though we're taking momentum about point B. So the next is the UDL, uniformly distributed load. So minus 7 times 8 as a bunch of load times half of the distance, which is 8 squared over 2. It's equal to 0, because there's no other reaction. B will not generate bending about, the reaction B will not generate bending where B is. It will not generate bending where B is. So from here we have that reaction A is equal to 6 times 4, that's 24. 24 minus 7 minus 7 times 64, that is 42, all over 8, which are going to equal to 31 kilonewton. ROA is equal to 31 kilonewton. And this is 32, 64, 32. A squared is 64. So the same way, total MA is equal to 0. To get reaction B, I have 8 RB. 8 RB minus 6 times 4. That's the same distance from E to C, perpendicular distance, minus 7, 8 squared over 2. RA is still equal to the same 31 kilonewton. RA is equal to the same 31 kilonewton. RB is equal to 31 kilonewton. RA is also equal to 31 kilonewton. So now we have gotten the reactions. The next thing is to calculate bending moment. To calculate bending moment, I start from point A to calculate bending moment. For the fact that in point at support A, there's only vertical reaction A that's available. That's 31 kilonewton. Vertical reaction A. There's no horizontal reaction, even though the support A can resist horizontally, but it doesn't have, because the whole load we are vertically down. The whole load were vertically down. None of the load is horizontal. So it is the load, the action that generates reaction. It is the action, the load that generates reaction. And in this case, there is no horizontal action. And as such, there is no horizontal reaction at point A, even though the support resists horizontally. The support has a capability of producing horizontal reaction, but it could not this time because there is no horizontal action or horizontal load against it. So at A, if we're taking moment along AC, the moment at A, horizontally at point A, the moment at point A is 0, and at A is equal to 0. Take moment at C, the moment at C, M at C is also equal to 0 because there is no horizontal load to generate that could be perpendicular to the distance AC. There's no horizontal load to be perpendicular to the distance AC. That's why there could not be generated moment along AC. But by the time we get to from C now to ME, at ME, the reaction A will come to play now. The reaction A will generate moment because the distance CE is perpendicular to reaction A. So M at E, looking at where we started, M at E is equal to reaction A, which is 31, times the distance, which is 4. That's the distance, which is 4, minus, because the load is against reaction A, minus 7 times 4 squared over 2. We are just at point E, where 6 kilonewton is. And so at that point, 6 kilonewton will not generate moment because there's no distance from itself. So it won't generate moment. So at point, the moment at E, so the moment at E is equal to 31, that is 124 minus, this is 4 squared, that's 8 times 7. 8 times 7 is 50, is 57 or 56. 8 times 7, about that's 57. That's about 7. So then that's moment at E, at moment at D. Moment at D is equal to reaction A coming to play. 31 times 8 minus 6 times 4. 6 times 4 minus 6 times 4. That's the moment at B. That is moment at D. Yes, moment at D. Moment at D is 7. This is 7 times 8 squared over 2. That gave 0. The moment here is about 64. Moment at E is moment at E forget moment at A. Then here the moment at D is equal to 0. Then the moment along DB, the length DB is parallel to all these forces. So it will not generate moment along B. The moment at D here, 0. So the moment at B is equal to 0. The moment at B is equal to 0. So the dependent moment diagram will look like this. This is the frame. At C, the dependent moment is 0. At the middle, that is at E, the moment at the middle. The moment at the middle is 68. So, and the equation is quadratic. 68 kilonewton meter positive. At C, moment is 0. At D, moment is 0. Is 0. And there's no moment at B. This is the bending moment diagram. Then talk of shear force. Along AC, because there's no horizontal force that will be across AC, shear force will not be generated. But from D, shear force from D will be equal to shear force at C, is equal to 31 kilonewton. That's the value of reaction A. As the load is, we are moving along CE, the shear force becomes 31 minus the load, which in this case is 7 times 4, which is 31 minus 28, which is about 3. 31 minus 28, which is about 3 kilonewton. Still positive at this point. Then minus 6, which is minus 3 kilonewton. Then the shear force at D is 31 minus 7, that is minus 7 times 4, 28, that gave us 3. Minus 6, that gave minus 3. Minus 3, minus 7 times, minus 3 minus 7 times 4, which is minus 3 minus 28, which is minus 31. Minus, at getting to D, minus 1 meets reaction B, which is also 31, and closes up to 0, minus 31 plus 31. So the shear force now the shear force diagram looks this way. At D, from A to C, there's no shear force. At D, the shear force is 31 kilonewton. It starts to reduce. At the middle, it reduced to 3. It reduced to 3 here. This positive. And continue. At the end, it reduced to minus. It comes to minus 31, which meets reaction B as 31 and closes. So this is also 31 kilonewton. That's the shear force. This will be a straight line. That's shear force diagram. Straight line. So the normal force. Normal force is the total load, which is 7 times 8 plus 6. 7 times 8 7 times 8, that's 50, I think 56 plus 6, that is 62. So that's the normal force. And that's 62. That normal force is this way and this way, which is 31. To draw the diagram of the normal force, look at the frame. Thirty-one kilonewton, 31 kilonewton throughout. 31. That's why it's rectangle. That is normal force diagram. This is shear force diagram. This is bending moment. This is 56. So we've been able to get both the reactions for this frame, got the bending moment values, got the diagram, got the shear force diagram and values, got also the normal force values and diagram. That is how to calculate, analyze this simply supported frame that is determinate. Thank you very much. That's the